Hello everyone. In this video, we are going to cover chapter 3.1, representation of preferences. In everyday life, we are making all kinds of decisions or choices. We choose whether we go camping or go to the beach this weekend. We choose whether we go eat outside or prepare food ourselves and go to a movie later on with the money saved. Whenever we are in a supermarket, we also choose what do we purchase. In all those instances, we are solving some kind of constraint optimization problem. For example, I may be a person who prefers go camping than going to the beach, but I eventually choose to go to the beach. And the reason behind that is that I may be financially constrained or I may be time constrained, and I know that going to the beach is both less time consuming and less costly than go camping. So if I were to choose at no cost between go camping or go to the beach, I would choose go camping. That is my preference. But as a result of a constraint optimization problem, and because of my time constraint and my budget constraint, I can only choose to go to the beach. The basket of goods that everyone leaves the supermarket is also likely to be different. What we choose to purchase from the supermarket depends on a lot of factors. Our preferences, the most importantly, but also our budget constraint. We may also have different kind of preferences over different kinds of goods. For example, if we need to purchase a toothpaste or kitchen towel, that we are going to purchase that anyway, and the purchase decision is not going to depend on our income. Regardless if we get a pay raise or a pay cut, we are going to purchase probably the same amount of toothpaste and the same amount of kitchen towel anyway. However, in cases when we get a pay raise, we may decide to treat ourselves and purchase a chocolate cake in the evening. And in cases when we are taking a pay cut, we may not purchase the chocolate cake, and we may even reduce the amount of snacks that we purchase normally. And we can see in such examples, the toothpaste and the kitchen towel are very different goods from the chocolate cake and the snacks that we are purchasing. And those can be modeled and reflected using the consumer theory that we are going to learn in this chapter. So by the end of chapter 3, we will learn how we model those questions. And in the chapter 4, we will learn how we solve those problems for the optimal choice. So this is the overview of what we are going to see today. We will first define a market bundle. We will then define preferences and some assumptions about preferences. More specifically, we will assume that consumers have complete, transitive, and monotonic preferences. Those three assumptions are what we think a rational consumer's preference will behave like, and we will get more into detail what exactly those three assumptions mean. And lastly, we will make a distinction between ordinal and cardinal ranking. A market bundle is defined as a collection of goods and services that a consumer consumes. So for example, we can have two bundles. Bundle 1 that contains a dozen eggs, 4 apples, a pair of shoes, and 2 pounds of beef. And bundle 2 that contains 2 dozen eggs, 2 bananas, a pair of jeans, and a lottery ticket. Those two bundles both contain eggs of different amounts, and they also contain different goods. And in real life, we can imagine that what a bundle can possibly contain is much more complicated than what is stated here. Here we have 4 goods in each bundle, but in real life, the bundle that we purchase from, say, the supermarket can contain tens or even hundreds of different kinds of goods. And to simplify our analysis, we are going to focus on bundles that has only 2 goods. And we use food and clothing as an example, or in general, we can say that consider different bundles consist of good X and good Y. So we may write that bundle A has 4 units of food and 3 units of clothing, or more simply, bundle A equals to 4F. So bundle A equals to parentheses 4F, comma 3C. And if we know that it is food and clothing that we are talking about, we can also write that A equals to 4 and 3. So similarly, if bundle B consists of 2 units of food and 4 units of clothing, we can write B equals to 2, 4. And in general, we consider a bundle that consists of certain units of good X and certain units of good Y. So here, the bundle 1 can be written as bundle 1 that consists of 3 units of X and 3 units of Y. In the next slide, I'm going to draw some of the bundles on the graph. So here is the bundle A and bundle B that we just saw. And it is a common convention that we are going to draw the first good on the horizontal axis. So on the horizontal axis, we are going to draw the number of food that we have in each bundle. And on the vertical axis, we are going to draw the number of clothing that we have for each of the goods. So here, the bundle A consists of 4 units of food and 3 units of clothing. So this is 1, 2, 3. Well, let's make it larger. So this is 1, this is 2, this is 3, and this is 4. And on the vertical axis, this is 1, 2, 3, and 4. All right, so on this graph, we can find bundle A that has 4 units of food and 3 units of clothing, which is going to be this point. Sorry about the drawing, it's kind of hard using my mouse to do it. So this is our bundle A. Oops. Okay, I can actually text here. This is our bundle A. Now, we can also draw bundle B that has 2 units of food and 4 units of clothing. So this is 4 units of clothing. This is 2 units of food. So at this point is our bundle B. All right. This is a basic graph of representing bundle A and bundle B on a single graph. Now, we cannot draw bundle 1 on this graph because bundle 1 is regarding two other different goods, X and Y. So good X and Y are not necessarily food and clothing. So even though we have 3 and 3, which are tempting to put bundle 1 over here, bundle 1 here, this is not bundle 1. So let me put this is not. Point 3, 3 is not bundle 1 because bundle 1 is in terms of good X and Y. So try to put here. All right, you can take a screenshot of this if you like. You should take notes on your own. Oops. I'm going to clear my drawings. All right. So with different kinds of bundles, we are going to define the consumer preferences. So given any two bundles, like bundle A and bundle B that we had touched just now, we can ask every single consumer, do you prefer one bundle over the other, or do you potentially like those two equally? So the bundle that is at question are bundle A with 4F and 3C, and bundle B with 2F and 4C. So the consumer may give you one of the following answers. So if the consumer says that she prefers bundle A over bundle B, then we write that bundle A is preferred over bundle B. So for this sign, it is not the larger than sign, it is the curly version of it. So we write it this way, and this is so if we say A is I can actually type it over here. So if we put, so let me erase this part, and let me say if we put that A is weakly preferred over B, this is saying that basically bundle A is preferred over bundle B. And conversely, if the consumer tells us that she prefers bundle B over bundle A, then we write in the other direction that B is preferred over A. It is also possible that the consumer likes the two bundles equally much. So the two bundles gives this consumer the same level of happiness, and later on we will use the term utility. So the two bundles give the consumer the same level of utility. And in that case, we say that bundle A is, so the consumer is indifferent between bundle A and bundle B. And we write it this way using this tilde. So this reads, bundle A is indifferent between bundle B, well, for certain consumer. It is kind of intuitive as we are comparing different numbers, right? So we may say a number is larger than, equal to, or smaller than, which is that the other number is larger than this number. So in this case, a bundle may be preferred over, may be indifferent between the other bundle, or that the other bundle is preferred over this bundle. However, those three are not the only answer that we may get. It is possible that the consumer tells us that, well, I don't know. I don't know if I like bundle A better or if I like bundle B better. I'm just undetermined. And we want to note this is totally possible. And we want to note that this is a different answer from saying that the consumer is indifferent between bundle A and bundle B. Because in that case, the consumer knows that she likes bundle A and bundle B equally much. And in this case, the consumer do not know and is undetermined whether she likes one better than the other. So this is a possible answer, but later on we are going to, but this is not a very interesting case, right? Because if the consumer do not know what she likes, then what's the point of finding a best choice for her when even she do not know what she likes to have? So later on, we will have some assumptions that rule out this kind of possibilities. And also we want to note that we are making the above arguments assuming that those bundles do not cost you anything. So for example, in the following statement, if someone says that I prefer to buy a Samsung tablet because the new iPad Pro is too expensive and I cannot afford that. This statement is not about preference. That individual, that consumer may actually prefer to have an iPad Pro over a Samsung tablet, but she decides to purchase a Samsung tablet because of the price of the iPad Pro is too high and it is not affordable to her. And this is actually a statement about the result of an optimal choice. So for that person, basically purchasing the iPad Pro is not within her budget constraint, and we will say what is meant by a budget constraint later on. And the best she could do is to purchase a Samsung tablet. We are going to make the following 3 assumptions about preferences. So the first one is completeness, the second one is transitivity, and the third one is monotonicity, which is intuitively known as more is better. And we want to note that those assumptions are not always true, and I'm going to show you some examples when those assumptions do not hold. But with those assumptions, it makes our analysis much more tractable in the sense that we can represent people's preference using the utility functions, which is what we are going to learn in chapter 3.2. And also, those assumptions are, well, in most cases, reasonable, and we expect that a rational consumer's preference to behave, the behavior of a rational consumer's preference will satisfy those 3 assumptions. So the first one, completeness, rules out the possibility that the consumer is undetermined between 2 consumption bundles. So under this assumption, a consumer can always rank any 2 bundles. So when we ask her whether you like bundle A or bundle B, her answer will be either I like bundle A better than bundle B, I like bundle B better than bundle A, or that I like bundle A equally as much as I like bundle B. And with this assumption, it will allow us to assign a utility value, which is the value of the utility function, to any consumption bundles. And we can analyze the problem more easily. And also, without this assumption, we are thinking that the consumer herself do not know what she wants, right? So if she do not know what she wants, what's the meaning of choosing the best outcome for her? It is unclear, and it is not very meaningful to analyze the problem without this assumption. So the second assumption is transitivity. We can understand this in a somewhat intuitive way. So for any 3 bundles, bundle A, bundle B, and bundle C, if the consumer already says that she prefers bundle A over bundle B, and that she prefers bundle B over bundle C, then it must also be true that she prefers bundle A over bundle C. And written in mathematical symbols, we say that if A is preferred over B and B is preferred over C, then it must be that A is preferred over C. And we expect this to be true for a rational consumer, which when regarding the consumption of goods, this is usually the case. But however, we can also find examples when this is violated. So for example, when looking at the pictures of Brad Clooney and George Depp, someone may find that, okay, I think Brad Clooney is more handsome than George Depp. But when comparing the photos of George Depp versus Johnny Pitt, someone may find that, all right, I think George Depp is more handsome than Johnny Pitt. However, if given the same person the pictures of Johnny Pitt and Brad Clooney, well, it's possible that the person finds that actually Johnny Pitt is more handsome than Brad Clooney, right? So certain kind of preferences that formulates a circle may have a reality, while the assumption of transitivity is violated. So we are when the assumption of transitivity is violated, again it makes it difficult to find the best solution, the optimal choice for an individual. So we are going to also, by assuming transitivity, we rule out this such kind of possibilities. The last one is monotonicity, which is intuitively known as more is better. And basically it is saying that having more of a good is better for the consumer. So here we are going to suppose that we have 4 different bundles. Bundle A that has 4 units of food and 3 units of clothing. Bundle B that has 2 units of food and 4 units of clothing. Bundle C that has 2 units of food and 2 units of clothing. And lastly, bundle D that has 4 units of food and 4 units of clothing. So we can see that when we look at bundle A and bundle C, bundle A has 4 units of food, which is strictly more than bundle C that has 2 units of food. And bundle A also has 3 units of clothing, which is strictly more than bundle C that has 2 units of clothing. And by the assumption of monotonicity, and by the assumption that we think people like more of the good, and the more the better, the monotonicity will imply that the person must prefer bundle A over bundle C. It will be a violation of the monotonicity assumption that if the person actually prefers bundle C over bundle A. And similarly, if we look at bundle B and bundle C, well, bundle B and bundle C has the same number of food, both have 2 units of food, but bundle B has strictly more units of clothing than bundle C does. So again, also by monotonicity, it must be that a rational consumer has to prefer bundle B over bundle C. And you can compare between bundle A and bundle D, and also bundle B and bundle D yourself to see that implied by monotonicity, a rational consumer or a consumer whose preference satisfies monotonicity must prefer bundle D over bundle A as well as bundle D over bundle B. And lastly, bundle D over bundle C. And here we can note that since by monotonicity, the consumer would prefer bundle D over bundle A and bundle A over bundle C, we can also say that by transitivity, so if the consumer's preference satisfies transitivity, she must also prefer bundle D over bundle C. So basically, in this instance, to conclude that a rational consumer must prefer bundle D over bundle C, we can use either monotonicity or transitivity. However, the monotonicity assumption need not always be true in real life, and eating pizza is always a good counterexample to this. So imagine that you are to eat a pizza. The first slice is delicious, it is awesome. The second slice, well, it's pretty good. The third slice, it's not bad. I will still eat it. The fourth slice, all right, I'm getting a little full, but I will do it. And if we were to eat a fifth slice, it's too much, right? So you will not be willing to eat a fifth slice, even if it comes at no cost. And if you were to eat a sixth slice, a seventh slice, or an eighth slice, you will have to be forced to do that. You will never do that like voluntarily. And so if someone would have to pay you, someone would have to compensate you to eat like 8 slices of pizza in one setting. So in this case, eating more than 4 slices of pizza is not making you better off. It is making you worse off. It is violating the assumption that more is better. So in this case, we say that your preference after the 4th slice of pizza no longer satisfies the assumption of monotonicity. And well, we will want to focus our analysis on the part where it is still, well, the monotonicity is still satisfied, so that we will focus our analysis on the part that you are concerned with eating the first 4 slices of pizza. All right? So I'm going to now draw the monotonicity on a graph. So same as before, we are going to draw the number of food on the horizontal axis and the number of clothing on the vertical axis. So let's just find a random point here. So let's say this is our bundle A. Bundle A is here. So by monotonicity, what we can know is that for any bundle that is within the region I'm drawing now, so those are dashed straight lines, both horizontal, and one is horizontal, the other is vertical, dashed straight lines. So for any bundle that is in this shaded area, we can conclude that we are going to prefer those bundles or those points over bundle A, right? Because if we look at a single point here, so if we look at point here, which is bundle B, this is bundle B. So we can find out the number of food and clothing each bundle has. So we can call this the amount of food that bundle A has, F superscript A, and this is the amount of food that bundle B has, F superscript B. So this is the amount of clothing that bundle A has. This is the amount of clothing that bundle B has. We can see that it satisfies, for any point in this shaded area, it satisfies that the amount of food it has is strictly larger than the amount of food that bundle A has. And also, the amount of clothing it has is strictly larger than the amount of clothing that bundle A has. So for any point in this region, this relationship, these two inequalities hold. And by monotonicity, it will imply that bundle B is, well, I didn't intend for this. it is just the curly sign. It is simply that bundle B is preferred over bundle A, right? So for any point in this shaded area, these two inequalities hold, and by monotonicity, so here by monotonicity, it will imply that the bundle B has to be preferred over bundle A. All right, let me clear the drawing here. So in the last part of chapter 3.1, we are going to make a distinction between ordinal and cardinal rankings. And the two terms may sound strange. So ordinal ranking only tells us the relative order in which we rank different bundles. And the cardinal ranking not only tells us the order in which we like different bundles, but also reflects the intensity. So basically, by how much do we like each bundle? And when we ask a consumer, when we ask a consumer the question we were asking before, do you prefer bundle A over bundle B? Well, most people can provide an answer to that question, right? So they can often make an ordinal ranking, but it is less easy to make a cardinal ranking. And so for example, we asked a person, how much unit more do you like bundle A than bundle B? It is a less straightforward question to answer, and most people do not have a readily available answer to that. And here we are using some notation that we are going to use in the next chapter, the utility function. So here I have this function, u parentheses A. This should read the utility of consuming bundle A. And I want to save a whole bunch of space, so I'm using this notation here already. So for here, this is the utility of consuming bundle B, all right? Which is UB. So this is UA, this is UB. So suppose UA is 2 and UB is 4. With ordinal ranking, this only says the relative preference over the two bundles. So using the fact that 4 is larger than using the fact that 4 is larger than 2, we can say that the consumer prefers bundle B over bundle A. And the same will hold if we change the numbers. So for example, if we double both numbers, if we, instead of putting the utility of consuming bundle A to be 2, and we put it to be 4, and instead of putting the utility of consuming bundle B to be 4, we put it to be 8, the same relationship holds. If we assume ordinal ranking, all we can say is that the consumer prefers bundle B over bundle A. Or if we do not change the utility of bundle A, but we change the utility of bundle B to be 3, we reach the same conclusion. However, if we were using cardinal ranking, it will suggest not only the relative preference of the two bundles, but also to what extent does the consumer like each bundle. So with this example, UA equals to 2 and UB equals to 4, with cardinal ranking will suggest that the consumer likes bundle B twice as much as bundle A, or that consuming bundle B makes the consumer twice as happy as consuming bundle A. We can also say that with cardinal ranking, the consumer consuming bundle B makes the consumer 2 more units happier than consuming bundle A, for some meaning that 1 unit of happiness might mean, which we do not know. But we cannot make those conclusions under ordinal rankings. So for the purpose of this course, we are only concerned with ordinal ranking. So we are basically, it is saying that we can make some monotonic transformation of our utility functions. So for example, we can double the number of our utility functions and all the results will hold exactly the same. And we can add a constant to our utility functions, and any kinds of such linear monotonic transformations will not change our conclusions. All right. So this is the summary of chapter 3.1. We first define what a bundle means. A bundle is a collection of goods and services that one might consume. And when we know what the underlying goods we are talking about, for example, food or clothing, or good X and good Y, we can write as simple as bundle A equals to parentheses 3, 4, which means 3 units of good X and 4 units of good Y. And we also define preferences. So consumers have preferences over different bundles. And for any two bundles, a consumer either prefer bundle A over bundle B, or prefer bundle B over bundle A, or that the consumer is indifferent between bundle A and bundle B. But those preferences need to behave nicely to represent the preference, or to represent the behavior of a rational consumer. And we assume that the consumer's preferences satisfy the 3 assumptions, which are completeness, meaning that the consumer is able to make a comparison between any two bundles, that it is transitive, meaning that if the consumer prefers A over B and B over C, then she must also prefer A over C. And lastly, monotonic, which requires that when there is more good in a bundle, the consumer in a bundle than another, then the consumer will prefer the bundle that has more good. And lastly, we make a distinction between ordinal ranking and cardinal ranking. So ordinal ranking only reflects the order of the preference, while the cardinal ranking also reflects the intensity of preferences. And we will not learn in this course, but if you take future classes in economics, and when you learn consumer theory with uncertainty or game theory, you will be assuming the cardinal ranking for the analysis. All right, so this is the end of chapter 3.1. I will see you next time.